in a silence deeper than anything humanity has ever witnessed, far beyond the orbit of Neptune, the Voyager spacecraft continued drifting through a region once thought to be empty. The mission expected nothing but frozen dust, cold vacuum, and temperatures approaching absolute zero. That was the prediction. That was the model. That was the assumption. But when the first data started showing unexpected levels of heat, energy, and activity, scientists initially believed the sensors were malfunctioning. How could a region so distant from the sun display signals resembling the behavior of a burning star? Nothing that far out should be active. Nothing that far out should be hot. Nothing that far out should be alive with energy. Yet, the data was clear, continuous, and consistent. After nearly half a century in space, Voyager 1 had reached the true boundary of the sun's influence. And what it found there was not darkness. It found fire. To understand how we arrived at this moment, we must return to 1977, to a launch made possible by a rare planetary alignment that occurs only once every 176 years, and to a mission that was never supposed to endure this long. Let's begin with the impossible discovery itself. When Voyager 1 crossed the Heliopause in 2012, it entered the sun's true boundary of influence, the point where the solar wind begins to lose its strength against the interstellar medium. For decades, scientists had speculated about this frontier. Some imagined a calm fading of solar influence into the vast cosmic ocean, a quiet transition into interstellar space. Others predicted a turbulent region where opposing forces would violently collide, creating an invisible barrier. What Voyager detected was neither silent nor simple. Its instruments recorded an extreme rise in plasma temperature, reaching nearly 50,000 degrees. Nothing so distant from the sun should display such heat. The mission had anticipated energetic intensity, not cold emptiness. The data did not show flames like those on Earth, but instead extremely energetic particles moving at such high velocities that they carried immense thermal energy. These readings were not isolated anomalies or random spikes. They were structured, consistent, and sustained. This was not a malfunction. It was a discovery. That region became known as the Wall of Fire. It was not a physical wall, but a boundary of energy and pressure where the solar wind is compressed by interstellar gas. At this frontier, the density of plasma increased dozens of times compared to the space behind the probe, while the velocity of the solar wind dropped almost to zero. In simple terms, the wind of our star was colliding with the wind of the galaxy. Earlier, Voyager's instruments had already detected the termination shock, the region where solar wind slows abruptly and plasma compresses like ocean waves crashing against a frozen shoreline. But something even more dramatic lay beyond that. Years later, Voyager 2 crossed the same boundary and confirmed the same phenomena, proving that the Wall of Fire was not an isolated event, but a permanent feature of our solar system. The heliosphere revealed itself not as a static bubble, but as a dynamic structure that pulses with solar activity. When the sun becomes more active, the bubble expands by billions of kilometers. When it calms, it contracts again. The boundary is alive with pressure and motion, a breathing frontier marking the edge of our star's domain. Beyond Neptune, the sun still exerts influence through a continuous stream of charged particles known as the solar wind. This flow spreads in every direction, forming an immense magnetic bubble called the heliosphere that envelopes the entire solar system. It functions as a shield against cosmic radiation originating from the galaxy. Like any shield, however, it has a boundary. That boundary is the heliopause, the point where the solar wind begins to weaken as it encounters the interstellar medium. For decades, scientists could only speculate about its true nature, imagining either a violent collision zone or a quiet transition. The Voyagers were sent to reveal the truth. What they discovered reframed the meaning of that boundary. The heliosphere is not merely a scientific curiosity. It plays a vital role in Earth's protection. By deflecting the majority of galactic cosmic radiation, it preserves the atmosphere and helps make life possible. Without this shield, galactic particles would destroy essential molecules, strip away the ozone layer, and expose the planet to lethal levels of radiation. The protection is not abstract. It is atmospheric and biological. The frontier of the solar system is not just a distant line in space. It is a defensive barrier that safeguards everything living on Earth. The measurements from the Voyagers revealed that this protective bubble is dynamic. As the probes traveled farther from Earth, their instruments recorded plasma density, temperature, magnetic fields, and energetic particles, gradually showing that the solar wind weakens with distance. The energy that once flowed freely becomes pressed back by the interstellar medium. In simple terms, the wind of our star collides with the wind of the galaxy. The heliosphere was revealed to pulse according to solar activity. When the sun becomes more active, the bubble expands by billions of kilometers. When solar activity decreases, it contracts again. The boundary is not fixed. It responds to the rhythm of the star. These discoveries also expanded our understanding beyond our own system. Every star possesses its own protective bubble known as an astrosphere. If a stellar wind is too weak, its planets remain exposed to radiation. If it is too strong, planetary atmospheres can be stripped away. The sun represents a rare balance, strong enough to protect, yet stable enough to preserve. This equilibrium may explain why Earth has remained habitable for billions of years. The frontier that Voyager crossed is therefore not merely the edge of solar influence. It is the edge of a life-sustaining system operating in delicate balance. For years, scientists believed that when Voyager crossed the Heliopause, it would encounter a completely different magnetic field, one oriented in another direction and clearly separated from the sun's domain. The expectation was logical. If the Heliopause marked the true boundary of solar influence, then beyond it should exist a distinct magnetic environment belonging solely to interstellar space. Many imagined a sharp rupture, a sudden shift in direction, an unmistakable dividing line between our system and the galaxy beyond. But that is not what the instruments recorded. Instead of a drastic reorientation, the data showed that the internal and external magnetic fields were almost perfectly aligned. This was not a violent break in cosmic structure. It was continuity. The transition from solar space to interstellar space was not chaotic, not abrupt, not a tearing of magnetic fabric. It was smooth, subtle. The boundary behaved less like a wall and more like a seam. The expectation of collision gave way to something far more intricate and unexpected. The alignment indicated that the frontier between the solar system and interstellar space is not a sudden rupture, but a gradual transition where the magnetic lines of the sun and the galaxy connect like threads woven into the same cosmic fabric. The discovery suggested a level of structural coherence that had not been fully anticipated. Rather than existing as isolated domains divided by sharp boundaries, the sun's magnetic influence appears intertwined with the surrounding galactic environment. This revelation redefined the nature of the Heliopause. It is not merely a pressure boundary where solar wind meets interstellar gas. It is a region where magnetic structures interface and connect. The frontier is not a cliff, but a gradient. It is not a barrier, but a transition zone. In revealing this alignment, Voyager demonstrated that the edge of our solar system is less a border and more a junction, a place where stellar and galactic forces converge in continuity rather than confrontation. The Voyager mission began in 1977 with a clear objective: explore the outer planets and reveal what existed beyond the reach of Earth-based telescopes. Each spacecraft carried advanced scientific instruments, high-precision cameras, and a golden record containing images, sounds, music, and messages representing life on Earth. The mission was only possible because of a rare alignment of the outer planets, an event that occurs once every 176 years. This configuration allowed the Voyagers to use planetary gravity as propulsion, conserving fuel and dramatically extending the mission's reach. Voyager 1 revealed unprecedented images of Jupiter, showing storms larger than Earth itself, and of Saturn, whose rings shone like ice suspended in the cosmic void. Voyager 2 followed a longer path, becoming the only human spacecraft to visit Uranus and Neptune up close, delivering the first detailed images of those distant blue worlds. After those historic encounters, the spacecraft faced a silent decision. There were no more planets to visit. The mission could have ended. Instead, the space agency chose to let them continue, allowing them to move beyond Neptune's orbit and into the unknown. Even after more than 4 decades, their signals still reach Earth from billions of kilometers away. They proved that the boundary of the solar system is not an ending, but a transition. They revealed that the sun is not merely a source of light, but a guardian, and that our existence unfolds within its cosmic breath. Beyond the wall of fire, both probes continue traveling silently through interstellar space, carrying humanity's voice across the stars with them. The frontier they crossed demonstrated that the heliosphere is not a static barrier, but a dynamic shield shaped by interstellar pressure and solar activity. If the edge of our own star burns with such structure and energy, the document asks an open question: how many other fires remain undiscovered in the depths of the unknown universe? The Voyager's journey transformed our understanding of what lies beyond the sun's influence. They showed that the boundary of our system is alive with pressure, motion, and magnetic continuity. They revealed that our star's protective bubble is essential for preserving life. And now, as they continue drifting farther into interstellar space, they stand as enduring symbols of exploration, not as machines that reached an end, but as messengers that crossed a threshold. The fire they found was not destruction. It was revelation. Voyager 1 was sent to explore planets. It was never meant to discover fire in the dark. Beyond Neptune, scientists expected frozen dust, cold silence, and near absolute zero temperatures. Instead, the spacecraft found a boundary alive with extreme energy, plasma, and pressure. It detected temperatures near 50,000 degrees in a region where nothing should burn. It crossed a frontier where the solar wind slows to almost zero and plasma density increases dozens of times. It revealed that the edge of our solar system is not an empty void, but a dynamic zone where the wind of our star collides with the wind of the galaxy. It also showed something even more profound. The heliosphere is not just a scientific structure. It is a shield. It protects Earth by deflecting most cosmic radiation, preserving the atmosphere and making life possible. Without it, essential molecules would be destroyed, the ozone layer would be stripped away, and our planet would be exposed to lethal radiation. The boundary Voyager crossed is the outer limit of that protection. And when scientists expected a violent magnetic rupture at that frontier, they found alignment instead. The external and internal magnetic fields were almost perfectly connected, woven together like threads of the same cosmic fabric. The solar system does not end abruptly. It transitions. After 49 years in space, Voyager 1 continues traveling beyond the wall of fire, still sending signals back to Earth from billions of kilometers away. It carries the golden record, the voice of humanity, into interstellar space. It proved that the edge of our system is not a final line, but a doorway. The real discovery was not just heat at the boundary. It was this: the darkness beyond our sun is not empty. If the frontier of our own star burns with such energy and structure, how many other unseen boundaries exist across the galaxy, waiting to be revealed? Voyager 1 has not reached the end. It has shown us that there may be no true end at all. If you want to continue exploring the hidden frontiers of space and the discoveries still arriving from the farthest human-made object ever built, subscribe and stay with us. Because the next signal from the edge of interstellar space may redefine what we think the universe is. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts,